Hey there, it's Jason from Codemanship with an early morning video diary entry today. Before we get into the topic that I want to discuss, please like and subscribe if you're enjoying these videos and ring the bell for notifications. YouTube loves that. So, small delay, long queue. So recently I posted a video demonstrating how in queued systems, for example, a supermarket checkout, if there's a small delay in processing at the checkout, that can actually lead to long checkout queues. And I demonstrated that effect with a multi-threaded code example where we had two threads, one of which I'm calling the customer thread. Let's just take a look at this code. The customer thread, which is the main thread, is in a little loop, looping 100 times, adding features to a backlog. In other words, adding items to a queue. And it does that every 10 milliseconds at the moment. And then we have a developer thread with its own loop, little while loop there, that is working through this backlog whenever it's not empty, and taking items off the backlog and completing them. In other words, it's calling a method called complete, which simulates the delivery of that particular feature into production. And inside each feature object, it's very, very straightforward. It's just recording the start and the completion time for each feature. In other words, when was it created and added to the backlog, and when was it actually completed by the developer thread, by that separate thread. And that allows us to calculate the lead time or the wait time. How much time does the customer have to wait for that feature to be delivered into production? Now, in my previous video, I demonstrated how a very small delay to the development time. So each of these threads sleeps for 10 milliseconds and then does another cycle. If we have it sleep for just a little bit longer, if we make development just 10% slower, counterintuitive to a lot of people I know, but people often assume, well, that's going to mean that the lead time is going to be 10% more. No, sir. What actually happens is that it creates an exponential increase in the lead time. And just to demonstrate that, so at the moment, development team and customer team are kind of in sync. The customer is adding features every 10 milliseconds. The developers are completing features every 10 milliseconds. And when I run this this command line program with these two separate threads, we'll get an idea of what the average lead time is when they're in sync. So let's run that. So it's 100 features. It'll take about a second. So we have an average feature lead time of 17 milliseconds. That's not bad. It is slower than it's when I'm not recording video because my computer is busy, but it's still pretty good. And you'll notice I've added some extra outputs here. I'm also recording the total time it takes to complete all 100 features, which is about 1200, 1300 milliseconds. And it's also recording the longest, there's a little line here that records the longest that the backlog gets. So at its worst point, there are 4 items on the backlog. Let's run it again and get an average on that. Okay, that's a little longer. 11 features on the backlog. My computer's very busy. Okay, there we go. So we're in a sort of a ballpark there. We kind of get a feel for how long it takes to complete each feature, and how long it takes in total to complete all of the features, and also how long our backlog is getting as we're running this code. Now, when I demonstrated in the previous video what happens when we make a small change, a tiny change to the productivity of the development team, we make them 10% slower. Let's see what that does to the lead time, the total delivery time, and the length of the backlog. And off it goes. So yeah, the lead time has increased quite significantly. The length of the backlog at its worst has increased very significantly. But notice there's not much change in the total delivery time, just a small change there. And that is interesting. And that's what today's video is about, really. Because people confuse development teams working faster with development teams delivering sooner. Sooner and faster are not the same thing necessarily. And in agile software development, our goal really is to deliver sooner, not necessarily faster. We want to be as responsive to new requirements and to change and feedback as we can be. And that requires us to have short lead times. And if we have short lead times, that kind of implies we're also going to have short backlogs. Short backlogs are a sign of that. But you'll notice that the total delivery time only changes a little bit. So we're almost as fast as we were before in terms of delivering the whole package, if you like, the whole queue. But we're far less responsive. So we're delivering just as fast, pretty much, but we're not delivering just as soon. We've become a lot less responsive. Let's make another little change to it. So now they're 20% slower. Let's see what that does to our backlog. Just having a little think. Computer is very busy because I'm also recording video on it. Okay, so that's made quite a difference to the feature lead time, and our backlog is growing as well. Let's just run that again, see what difference it makes if you get sort of an average. Yeah, so, oh, that's interesting. Okay, do one more. So, yeah, that's quite a long backlog there. But again, it's only a small difference in the total delivery time. So let's say that 100 features, that 1200 or 1300 milliseconds represents a year's worth of work. We're now maybe taking a year and a month or a year and 2 months to do the whole thing. But in terms of responsiveness, we're way less responsive to change and to feedback. So that's what this video really is about. It's about the difference between sooner and faster. And Agile really is all about sooner. Now you get a similar effect. Let's just change our team. Let's make our team productive again. We gave them a bit of codemanship training and now they're more productive. Let's see what happens if we make our customer faster. So let's take a look at our customer loop there. So let's see what happens if the customers add features to the backlog every 8 milliseconds instead of every 10 milliseconds. Now again, this is counterintuitive to a lot of people. They think, well, it won't make any difference because the development team are just as fast, that we're not changing how fast the developers are at completing features. But let's see what happens to the lead times and to the backlog when the customer starts to overload the team with work. It's a similar kind of effect, really. They really do need to be in sync in order for the team to be responsive. The customer can't be scheduling work faster than the team can perform it, because when they do, that queue builds up, that backlog builds up, and the team becomes less and less responsive. And I see that in the real world over and over again. Teams that are overloaded, managers who are trying to get 100% from the team, and they think that's the goal. The goal is to use the team 100%. They must be busy all the time. So let's load up that work. Let's load up that work fast. But what that does is it destroys their responsiveness. It makes them far less agile because you end up with long backlogs and long delays, long lead times. So really, they need to be in sync. So let's just run it again when they're in sync. So now we've given the customer a bit of training now as well. Okay, and then we're back to a short backlog and shorter lead times. But again, the total delivery time is not changing that much. So faster and sooner are not the same thing. And if the goal is sooner, in other words, being more agile, being more responsive, then we need to be very, very careful about keeping the scheduling of work in step with the delivery of the work. And if you want to speed that system up, what you need to do, but actually, let's keep the customer just as rapid as they were before. But let's see what happens if we speed up the developers a little bit, just a little bit. So we're giving them a bit more codemanship training, and now their tests all run faster. Let's see what a small change, an improvement in the delivery time makes. Not much. Let's try again. Okay, not quite sure how this is working. Okay, that's what basically, just to qualify, I'm running video recording software at the same time, and it keeps my CPU rather busy. But when the CPU is not busy, we get shorter lead times and a shorter backlog. And a short backlog and short lead times are a sign of a healthy, agile environment, a healthy, agile system. Long lead times and long backlogs are signs that you're not really agile, you're not really being responsive. You're kind of working through a plan, basically. You're chugging your way through a plan rather than being in a position to respond to feedback. So this is all about responsiveness. So that's today's video, sort of following on from the small delay long queue video with an updated code example. I will commit and push this, and you'll be able to take a look at the code. I'll post a link to the GitHub repo in the description below. You may notice as you go through it that it is slightly different in a number of ways, one of which is that I fixed a bug. So I'm going to finish by talking about the bug that I fixed. So the code here that you'll see, which is part of the developer thread, that separate thread, this code originally was outside of this thread. It was in the main thread. So what was happening was, I should have guessed this. What was happening was that we were getting an output before the work had been completed. In other words, the developer thread was still working, but we were calculating averages and so on and so forth and displaying those before it had actually finished. So I fixed that by putting it in the developer thread. So it only does this after the developers completed all 100 items. So it is the complete work. So we're getting more realistic figures now. So there you go. I'll post that code on GitHub and you can have a play and take a look if you're a Java developer. But that's today's video. Faster is not sooner. Sooner is not faster. They're not necessarily the same thing, although obviously there is a relationship between how fast developers can complete features and those lead times and overall development time. But again, we've only made a small difference to overall development time. And what we've made a big difference to is the lead time. And that's what Agile is all about. Okay, so until the next video, take care, stay safe.